functions, particularly the domain and range. I'm going to first of all just talk a little bit about what a function is, just in case you don't know, so you can always skip the next about 15-20 seconds if you want. Now before, you'll have done loads of this, what we call substitution, where you might have an expression like this, an algebraic expression, and someone might say, what's the value of this, when x equals like 4? And then you substitute it in, and you go, 3 times 4 is 12, take away the 2 is 10. Okay? What we're going to do here is basically a system of mathematical notation where we're going to take that expression, so it defines an expression and gives it a letter, like naming it. So instead of saying that expression, I'm going to say expression f, or in this case, function. F of what we call f of x, right? And f is usually where we start. So an example here, f of x equals 3x minus 2. That's the exact same expression I had earlier. And we've literally named it. So I now call it f of x because I've defined it. I've said f of x is 3x minus 2. Whenever I talk about f of x, this is the expression I am talking about. It's literally naming something. And g is usually the next letter we use. So g of x equals, in this case, x squared. Then we might use h. I mean, you can effectively use any, but by standard mathematical notation is you start with f, use g for the second one, and h, and so on after that. And so if you had an expression then after that, once you've defined it, if you said, f of 4, what it means is substitute 4 into the expression f of x. And then, again, it's going to have exactly the same answer because it's exactly the same maths. It's no different. So it's just a way of naming something. And if you had, say, f of negative 5, it's still exactly the same function. You just substitute it in. 3 lots of negative 5 is negative 15. Take away 2, we get negative 17. And if I then spoke about g of x, I've got g of x is x squared. G of 3 means substitute 3 into my expression. I think even if it's positive or negative, putting a bracket in when you're substituting is always a good idea. Obviously, 3 squared is going to be 9. Or g of negative 3, of course, it's why it's a good idea to put the brackets in. Negative 3 times negative 3 is also positive 9. Okay. The set of input values for a function are called its domain, right? So anything that you can put into a function is going to be its domain. The output values are its range. So the answers are the range. So, whatever the total, possible set of answers are, that is the complete range. Functions must have a unique output for every input. Interesting. Because this means this is positive 9. That's also positive 9. Well, this is true, though. Doesn't mean it can't be the same as another output. But there can only be one output. There can't be any ambiguity. You can't have an input that's got 2 possible outputs, is what we're saying there. Okay? Right, let's move on. So what about, remember, domain is inputs, the range are the outputs. So here I've got a function here, f of x. I'm now redefining my f of x. It's now 2x minus 3. And it's defined a range it's domain. It's defined a domain which is x is bigger than 1. So I'm allowed to put in all the figures bigger than 1 into my expression. Domain is x is bigger than 1, right? This one, g of x equals x cubed. The domain for this one is all real values of x. Now, real values are what you would think of as the numbers. Unless you've worked on complex numbers, every number you can ever think of is a real number. When something isn't real, it becomes a complex number. That involves the square root of negative 1, otherwise known as I. We have this notation for I equals the square root of negative 1, which is an imaginary number. It can't exist. It has to exist, otherwise maths falls apart. But if you haven't worked with complex numbers, don't worry. If the domain isn't stated, it means all the real values, which just means all normal numbers. All right, whether they're decimals, negatives, positives, whatever, that's all real numbers. Okay. The set of real numbers are all the numbers we work with, both positive and negative, not complex numbers, is the point. Right, write down the range of f of x. So the range obviously is the output. So here we have f of x. F of x is now x squared for all real values of x. So my domain is all real values. Okay, but my range, let's think about the graph of f of x. Here it is. It's a quadratic graph. You can see it's got that U shape. It starts off, obviously this will keep going off like infinitely, essentially up positively. So will this side. It gets down to this point here, which is obviously 0. That's actually the minimum of this graph. But any other answer to it, remember the y values are the answers, then, you know, if you had, well, let's do a couple actually. The range for this one is basically f of x is greater than or equal to 0. You know, if I put in any value into this, let's put 3 into it. Obviously, we know 3 squared is 9. I could put into it negative 5. Well, negative 5 squared is positive 25. You know, all of the range is going to be greater than or equal to 0. That's my range. Okay, so the y values are the range. Or rather, the limits of the y values of the range. Right, f of x equals 6 minus 4x. So I've redefined my expression there, my function. And I've also got a domain on this one. I've got a domain which is x is all the way from negative 2 up to 3 and includes both ends of that as well. So I might start thinking about, okay, well, what would my graph look like? Well, let's put in f of negative 2. Let's just try these extreme numbers and see what we get. F of negative 2 will be 6, take away 4 lots of negative 2. Well, 4 times negative 2 is negative 8. If I'm doing 6, take away negative 8, it's going to turn into an addition sum there. So 14. So actually my first thing up here, my coordinate, I'll put it in a second, will be negative 2, 14. How about if I substitute in 3 though? 6, take away 4 lots of 3, will be 6. Sorry about the writing, it's really bad. 6 take away 12 equals negative 6. So that down there will be 3. The coordinate will be 3, negative 6. All right, in fact, let's put those coordinates in. Negative 2, 14, because we put in negative 2, we got out 14. The coordinate down here is 3, negative 6, because we put in 3, we got out negative 6. And you can see between our two values, because we've got our limits here, we've got our domain, the input values. We can see the output values go between 14 at the highest, negative 6 at the lowest. So my range is f of x is between negative 6 and 14. It's got limits either side. Sometimes you'll find domains are open-ended on one side, so they go infinitely in one direction with just a limit, either a lower limit or an upper limit. Sometimes they're bound between two values. This one's bound between two values. Make sense? Let's hope so. So this time we've got another domain. This time the domain is everything less than or equal to 3. So 3 and down. And we need to work out what our range is going to be for that. So think about what happens to our function. You know, when we substitute our maximum value into it, obviously it will be 3 lots of 3. God, that's really bad, isn't it? Let's rewrite that. 3 lots of 3 is 9. Now, if you can, it doesn't take a huge leap, I think, to think if we go down from that, we substitute in 2, it's going to be 6. And as we put in negative numbers, it's going to go down. Our limit is going to be 9 is the upper limit, and then it goes down from that. So our range will be f of x is less than or equal to 9, because it's going to be from 9 downwards. Another one, I'll just see if I can write a little bit neater. G of x equals 3 minus 2x. So we've defined g of x, and then x is greater than or equal to 4. So from 4 up. Let's just think about what happens to here. First of all, I'm just going to substitute in the 4 into my function. Sorry, it's not f of x, is it? It's g. Let's change that to a g. Let's rub it out. Mr. Nice. Let's try and be a little bit neater, shall we? So let's call that I'm substituting 4 into g of x, which will be 3 take away 2 lots of 4, 3 take away 8, which is -5. Think about what happens as my x increases, because that's the minimum value. If I increase it, this part here is going to get bigger. And we're taking that away. So 3 take away increasingly bigger numbers. So my range is going to go downwards, isn't it? Because I'm taking away bigger and bigger numbers. So my range of g of x, the biggest it can be is -5. And then it's just going to get lower and lower and lower from there. Because the numbers are increasingly positive, aren't they? They're going from 4 upwards. I'm not substituting any negative numbers into this. So that will be less than or equal to -5. Okay, this one. Whew, okay, so I've got my range. My range is x is bigger than or equal to 1. So we're still not, there's no negative numbers going on here. It's only positive numbers. Let's think what happens to my expression as I put numbers into it. First of all, let's start with h of 1 will be 1 take away 5 over 2. So 1 take away 5 is -4. Divide that by 2, we get -2. Now, as my x increases, this number here is going to increase. So the -5 becomes less and less relevant. This number on top is going to get bigger and bigger and bigger. We're dividing it by 2, but it's still going to get larger. So -2 is my minimum. So the range of h of x is going to be from -2 up. So it's greater than or equal to -2. Hope that makes sense. Right. Go to the textbook. Do some questions, or any textbook. That page reference there references this book, which is now behind all my scrawly writing. Let's get rid of that writing. So this book here, the AQA Certificate in Further Mathematics, Hodder Education, blah, blah, blah. Yeah, so you can use any old questions, though, about this kind of thing. Go and enjoy.